Lesson 2.2.1 is all about noble gas envy, which means that the main group elements would like to have the same electron configuration as the noble gases. So for example, let's take a look at helium. Helium's got 2 protons and 2 neutrons in the nucleus. And since it's in period 1, it has 1 shell, which is really a happy shell because it's complete with 2 electrons. Neon, number 10, has 10 protons and 10 neutrons. And because it's in period 2, it has 2 shells of electrons, and they're both completely full. The first shell has 2 electrons, and its outer shell is really stable with the great 8, just like the other noble gases. Okay, so if everything wants to be like the noble gases, let's take a look at this card activity from the lesson. So for this first one, it says atomic number 3. That is lithium. And it specifies that there are 2 electrons in the first shell, and there's 1 electron in its outermost shell. Lithium's got 3 protons and 4 neutrons. I'm getting the number of neutrons because I'm looking at the average atomic mass, and I'm rounding it to the nearest whole number and subtracting off the atomic number. Okay, so how could lithium look like one of the noble gases that it's close to? It's in the same period as neon, but in order to be neon, it would have to gain 7 more electrons in its outer shell. So it's a lot easier if it can just lose 1 electron, and then it will look just like helium's noble gas configuration. So it's going to form an ion, Li+. Now, how did I get this plus? Well, before the electron left, there were 3 protons and 3 electrons, and that equals out to a charge of 0. But now, there are 3 protons and only 2 electrons, so that means the protons are winning. So overall, this lithium will have a +1 charge and have the electron configuration of a helium. Let's practice again. How about element number 4, which is beryllium? Beryllium's got 2 electrons in its first shell, and it's got 2 electrons in its second shell, 4 protons, 5 neutrons based on its average atomic mass. So if it wanted to be like neon, it would have to gain 6 electrons. So it's easiest for it to just lose 2 and be like helium. So this one forms a +2 charge, because now with 4 protons and only 2 electrons, you can see the protons are winning by +2. Atomic number 5 means that this one is boron. Boron's got 2 electrons in its inner shell, and it's got 3 in its outer shell. So also it has 5 protons, 6 neutrons. If it wants to be like neon, it would have to gain 5, so it's still easier for boron to lose those 3 electrons in order to be like one of the noble gases, which is helium in this case. It forms a +3 charge because there's 5 protons, and now there's only 2 electrons after it loses those 3. So that means the protons are winning by 3. Then we get to the halfway point. You'll see what I mean by that. Carbon's number 6. It's got 4 electrons in its outermost shell. It's got 6 protons, 6 neutrons. So it could either gain 4 and be like neon, or it could lose 4 to be like helium. So how do you know which it does? Well, you'd have to know what other element it's combining with, which will come up in the next lesson. But for now, we just say it loses or gains 4 and becomes a ±4. So it has 6 protons, and if it lost all 4 electrons, it would only have 2 electrons left, leaving a +4 charge. And if it gained 4 electrons and had 10 electrons, then it would have a -4 charge. Element number 7 is nitrogen. This is the crossover that happens here. Nitrogen's got 5 electrons in its outermost shell. So it could lose 5 and be like helium, or it could just gain 3 electrons to be like neon. So it's going to gain 3, and it's going to form a -3 charge. That's because it's always got 7 protons, and since it had 7 electrons and now it gained 3, it overall has a -3 charge. Oxygen is number 8. It's got 8 protons, 8 neutrons, 2 electrons in its inner shell, and it's got 6 in its outer shell. So it will be really happy to gain 2 electrons and have the great 8 and be like neon. Last two, fluorine is number 9. It's got 2 electrons, and then it's got 7 electrons in its outermost shell. It's got 9 protons, 10 neutrons. It's so close to being neon, it just needs to gain 1 more electron. And when it does, it forms a minus charge, so an anion. Again, that's because it has 9 protons and it usually has 9 electrons, but with this extra one that it gains, it forms that -1 charge. Finally, saved the easiest one for last, neon, which has 10 protons, 10 neutrons, already has the great 8 in its outer shell, so it gains or loses nothing, and it does not form an ion. That's why we always say the noble gases are unreactive, because they already have the perfect amount of electrons. All the other elements are just fighting each other for some electrons. And you'll notice that as you go across the periodic table, from lithium to beryllium to boron to carbon to nitrogen to oxygen to fluorine and then the noble gases, that everything in group 1A forms a +1 charge, meaning they all want to lose 1 electron, and then they'll go backwards 1 and be like the noble gas. Everything in group 2A wants to lose 2 electrons. Everything in group 3A wants to lose 3 electrons. And then everything in group 4A could go either way, plus or minus 4. Everything in group 5A wants to gain 3 electrons. Everything in group 6A wants to gain 2 electrons. Everything in group 7A wants to gain 1 electron. And everything in group 8A wants to stay as they are, so 0. So notice the pattern, +1, +2, +3, plus or minus 4, then it goes down, -3, -2, -1, 0. And that's it for this